Chapter 10.8, we're looking at graphs of polar equations. We're going to graph polar equations by point plotting, and then use symmetry zeros and maximum values, R values, to sketch graphs of polar equations. So to sketch this graph, R equals 4 sine of theta, we're just going to plug in some values here. So let's start first of all with 0. So this is our theta here, and this will be our R. So if we plug in 0, so we have 4 sine 0, and at 0 that is 0. So we are here. Then if we plug in pi over 6, so we really want to plug in every 30 degrees or every pi over 6 at least to see if we can find some good values to plot, and so we can get a good idea of what this picture looks like. So we have 4 sine of pi over 6, and pi over 6 is a half, so this ends up being 2. So at pi over 6 here, pi over 6, we're at 1, 2. Pi over 6, 2. Then let's plug in pi over 3. So 4 sine of pi over 3. Pi over 3 is root 3 over 2. So we're looking at 2 square root of 3. And if you plug that in your calculator, you find that's approximately 3.5. So at pi over 3, we're about 3.5. Then we can plug in pi over 2, and 4 times sine of pi over 2. That's 4 times 1, which is 4. So pi over 2, we're at 4. Then let's try 2 pi over 3. And then so that's 4 sine of 2 pi over 3. 2 pi over 3 is again root 3 over 2. So we end up getting the same value, 2 square root of 3, which is 3.5 here. Then we plug in 5 pi over 6. 5 pi over 6 is a positive 1/2 still. And then so the answer is 2. Then if we plug in pi, pi is 0. So 4 sine of pi, that's just 0. So we're back at that starting point. So if we start to go over again, say for instance we choose 7 pi over 6. Let's just try that. 7 pi over 6, just so you can kind of see what's happening here. 4 sine of 7 pi over 6, that's going to be 4 times negative a half, right? 7 pi over 6 is negative a half, so that's negative 2. So take a look at where we are. So it's 7 pi over 6. If it's negative 2, we're going to go in the opposite direction here, and so notice it hits the same exact point. So as we're going to pick more points, if you pick 4 pi over 3, we're going to get a negative value that goes in here, and so forth. And so it just repeats. So this is the graph of 4 sine theta right here. So try this example here. Sketch the graph of the polar equation r equals 6 cosine of theta. Okay, hopefully you try this out, plugged a bunch of points in. And so this is the graph, so it's over on the right side. You plug in 0, you get a 6, and then if you plug in pi over 6, you get 6 times root 3 over 2, which is 3 times square root of 3, or about 5.2. And then so you get these points here, and then it just repeats over again. So looking at this, we can tell that there is symmetry. Note in example 1 that as theta increases from 0 to theta, the graph is traced twice. Moreover, note that the graph is symmetric with the line, with respect to the line, theta equals pi over 2. So you see that here. It is symmetric across this line here. Had you known about symmetry and retracing ahead of time, you could have used fewer points. So the figure below shows the 3 important types of symmetry to consider in polar curve sketching. So we notice that we could do some tests in order to figure out whether something is symmetric over the line theta equals pi over 2, or symmetric with respect to the polar axis, or it's symmetric with respect to the pole. So notice that it goes on the other side. So notice this type of symmetry. Now what you do to plug it in is if you plug in, for example, if you want to know if it's symmetric across the line theta equals pi over 2, if you plug in negative and negative for both the r and the theta, you should get the same exact equation back. Same thing for here. If you plug in r negative theta, then you should get the original equation back. And then here, if you plug in just a negative r, you get the same equation back. So whichever one works, So, it would be symmetric across that particular like axis or so forth. So just to test that out here in this example, so negative r minus theta. So remember the rule or the property, if you have a negative sine of theta, that comes out as negative sine theta. If you had cosine of negative theta, what happens, because it's even, it's just cosine of theta. So if we try this here, let's go ahead and try this one, negative r negative theta. So what you do is you plug in negative r equals 4 sine of negative theta. And then, so notice what happens. We get negative r equals negative 4 sine theta. Then divide by negative, you get r equals positive 4 sine of theta. So notice that we get the same exact equation back. And so therefore it is symmetric with respect to the line theta equals pi over 2. So the same thing is true here with the cosine of theta. We know that it is symmetric across this line here, the polar axis. And so we've applied the test. So I don't need to run all three because we already know that it's symmetric across the polar axis. But I just wanted to plug it in just so you can see what happens with it. We plug in negative theta. So we plug in negative theta, we should get the original equation back. So r equals 6 cosine of negative theta. And so we remember, because it's even, it just becomes positive completely. So we get the original equation back. Now, just to kind of talk about this a little bit, the tests for symmetry and polar coordinates listed on the preceding page are sufficient to guarantee symmetry, but a graph may have symmetry even though its equation does not satisfy the test. So it could fail all three tests, but it still has symmetry. So it doesn't always work. Now, what I want you to notice is that equations r 4 sine of theta and 3 plus 2 cosine theta are of the form r equals f sine theta and r equals g cosine theta. Graphs of these forms have symmetry in the polar coordinates. So for sine, it's going to be symmetric with respect to the line pi over 2. And then the graph of r, as cosine theta, is symmetric with respect to the polar axis. So that may be very helpful also in figuring out where your symmetry is, and so you can, limit the amount of values you are plugging in order to sketch a graph.